So in the question they have provided that the M1 moves on this inclined plane having the inclination theta, and this it is connected by a string passing through the frictionless pulley with the block M2. So with mass M2. Now they have also provided that the M1, the coefficient of friction between this M1 block M1 and this inclined plane is given by mu. So, which of the following statements are true? In order to identify which of the following statements are true, let us see the options. In the options, you can see that the body will move up the inclined plane or body will move down the inclined plane. Such conditions are given. So we have to we have to verify in which case the M1 will be moving upward and in which condition or in the which case the M1 will be moving downward. So in order to find those conditions, first, let us analyze the diagram and first let us analyze what kind of forces are acting on the block M1 and block M2. So when we come to this diagram, in this scenario, first the force which is acting on the block M1 is it's a weight which is directed vertically downward, and when we divide this weight, when we resolve this weight force in the two components, perpendicular components respectively, then we get that m1g sine theta is a force which is acting downwards to the inclined plane and is in the direction of the incline is downward to is parallel to the direction of inclined plane, and m1g cos theta is the force which is acting perpendicular to the surface of contact of the block m1. So since this block exerts force of m1g cos theta to the on the wedge, then the same according to the Newton's third law, as it is the action, the same amount of force will be exerted by the wedge on the block. The same amount of force will be exerted by the wedge on the block, but it in the opposite direction. And for your kind information, the two forces which are acting are on the different bodies. So if the force acting on the M1 it will be normal force, that is equals to m1g cos theta, means its magnitude is equals to m1g cos theta. Now moving further, so here we can also see that the this mass m2 is having its way the force acting on the mass m2 is its weight, that is m2g. Due to this weight, due to this force, there is a generation of tension in the string which is in the upward direction, and this tension is transmitted throughout the whole string. So we can see that the same tension will stretch the block M1 towards the upward direction. So let us suppose the block is moving in the upward direction. Then if the direction of motion of the block is in the upward direction, then the frictional force will be generated in such a way that to oppose the motion of the block M1. In order to oppose the motion of the block M1, it will be generated downwards to the inclined plane, that is along M1g sine theta. So supposing that this block M1 is moving upwards, then it will move upwards if this tension which is equals to M2G is, if this tension force is greater than M1G sine theta plus frictional force, then in that case the block will move upwards. So we know that frictional force on the acting on the block M1 will be given as mu into N, where mu is a coefficient of friction between the mass M1 and the wedge. So here already they have provided in the question that mu is a coefficient of friction and N1 is the normal force acting on the block M1, and we have already found that what is the force, normal force acting on the block M1 is M1G cos theta. So I got that frictional force acting on the block M1 is mu into m1g cos theta. So when I substitute these values, I get that m2g is greater than m1g sin theta plus mu into m1g cos theta. So on the both sides, when I take out the g as common and when I cancel, I get that if m2 is greater than m1 of sin theta plus mu cos theta, then in that case our block M1 will be moving up to the plane. So this condition is the condition for the block M1 moving upwards to the plane. So option A is wrong. You can see, and option B is true, and option C is wrong. Moving to option D says that the block will move downward the plane. If so, let us find the condition if the block M1 is moving downwards. Supposing that the block M1 is moving downward, then in that case, as the direction of motion of the block is downwards, then the frictional force generated will be generated in such a way that in order to oppose the motion of the block M1, that is, the frictional force which is generated, it will be generated in the upward direction, that is, it is along the inclined plane. Then the frictional force which will be generated will be opposing the motion of m1, that is it will be directed along it will be generated upwards to the plane. So frictional force here generated is in the upward direction of the plane, and in the same direction the tension is also directed. The tension value we already know that it is equals to m2g, because this tension was generated because of the this force exerted due to the due to the weight of the m2. So the downward force which is acting on the block m1 is m1g sine theta. So this block m1 will be moving downwards if the m1g sine theta, if the downward force acting here sine theta, sorry, here it is sine theta, not sine theta. So if the m1g sine theta is greater than the sum of the frictional force and tension force exerted on it. So if it is m1g sine theta is greater than frictional force, we already know that it is equals to mu m1g cos theta plus the here tension is m2g. That is, if this when we solve this and when we take out the g as common and when we cancel, we get that m1 sine theta, if the m1 sine theta minus mu m1 cos theta is greater than m2, then in that case, that is when I solve this further, I get that m1 of sine theta minus mu cos theta, if its value is greater than m2, then in that case this block will be moving downwards. That is, the option D is true. We can see that the same condition is displayed over here. So our option D is true. So overall, our option B and D both are true.